Okay, in this brief little lesson, we're going to take a look at solving right triangles using the primary trig ratios. First, we're going to just talk a little bit about some key terms that you need to know as far as working with these sorts of problems. So the first term is angle of elevation. Think of an elevator. An elevator takes you from the ground floor up. Of course, it can take you down, but the key thing in this diagram, as you can see, angle of elevation, the way you would measure it is between horizontal. So if you were to stand up, put your arm straight out, and then use your other arm to go in an upward direction, and you create that angle of elevation, right? Similarly, angle of depression, again, putting one arm straight out, and then use your other arm, angle it to move towards the ground level, then you're creating an angle of depression. So again, the angle is between your two arms. If you're doing a little demonstration there, or as you can see in the diagram, it's either going in an upward direction or downward direction. So for example, this one here, you get a little sample problem just to quickly take a look at. Now with every sample problem, sometimes it's best to, to try to get some reference image if you can. So the ladder safety rule is 4-to-1. So what that basically means, for every 4 units up, the base of the ladder, or the bottom of the ladder, which is down here, which is what I'm pointing to, has to be 1 unit away from the wall. Now I say unit because the measurement here is in feet, could be meters, could be centimeters. It's just a ratio. That's all it is. Okay, just think of it that way. So if you're leaning a ladder against the wall, it creates an angle of elevation to a window of 70 degrees. Now, if it's an angle of elevation, it has to be from horizontal and then up to the window. Okay, so it has to be that kind of an angle that you're creating. So this is where you have to be careful with the interpretation. So then that means the base of the ladder, bottom down here, that's the ground, and then elevate up. I know it's not a window, but just a reference image. So the 70-degree angle is down there. So it often helps to create your own little diagram to make sure you can make some sense out of it. So the ladder is leaning against the wall. There's your 70-degree angle. You can put some capital letters for your vertices, label the 90-degree angle, and you have your right angle triangle. Okay. So if you're told the base of the ladder is 3 feet from the wall, and all that 3 feet would then be right here. Oops, just gonna move that. So there's your 3 feet from there to there. So this is the wall. There's your 3 feet. So if you're going to use the primary trig ratios, you need a little bit extra information other than just the angle, especially if you're trying to answer this question. Has it been set up safely? So what you're trying to do is determine if the ratio of the 3 here to the height fits this 4-to-1 rule. Now, if it's a 4-to-1 rule, if this base is 3, and we're using this as the same ratio, it's 4-to-1, then this cannot be more than 4 times as much, or should be about 4 times as much, which is 12. So if it's 3 feet from the wall, then it must go up 12 feet, and you're asked to prove this. So how do you prove it? Well, this is where your trigonometry is going to be important. So you have this angle, and you have your sides of the right angle triangle. Now the naming is important. So opposite the 90, that's your hypotenuse. Opposite the angle is this one here. Okay, so you can refer to this one as, in this particular case, as the opposite side. And then this would be the adjacent side, which you already have as a 3. So opposite and adjacent points to using a tangent ratio as your helpful trigonometric formula. All right, so your job is to show that x is equal to 12. I don't have x here labeled, but this is your opposite side right there. So that's your x. Okay, so you got to show that x is 12. All right, so how do you do that? Well, you set up your trigonometric ratio. So it's the name of the ratio, tangent. You need your angle, which in this case is 70, and then it's going to be the opposite side, which we don't know, it's x, so opposite the 70 is x, and the and the adjacent is 3. Now we have a formula that we can solve for x. tan of 70, use your calculator to find that. To get x, multiply both sides by 3, and you get approximately 8.2. Since x is 8.2, we wanted to show that x is 12 for it to be safe. If it's not, that ladder is not safe. Okay, so this is one little sample problem, but you need some trig ratios and some reference diagrams. We're going to go through a whole bunch more. Well, at least partially anyways from this one, this little intro here. So again, second problem here, solving right triangles. You have to know what works. Sometimes you can use trig ratios. Sometimes you can use Pythagorean theorem. Here it has to find all the missing side lengths and angles in the triangle below. So the triangle is given to you here. So you need to find that angle, and this missing side. So never a bad idea to write down what you're missing or what you have to find. So now because you're given two sides in this right angle triangle, it should not be a big deal to find the third side, little a there, because you can simply use Pythagorean theorem. All right, so you are given some information which you can use to help solve. So your formula here would be your hypotenuse squared is equal to the square of the sum of the squares of the other two sides. There's your Pythagorean theorem. If you rearrange that, because you're trying to find a squared would be equal to c squared minus b squared. Substituting in the values, and then you easily get a squared, which allows you to get a. So that is taking care of one of the issues. Now the other thing you need to find is angle B and angle A. Now how you're going to find that is using your trig ratios. So once you have a side length here, to find angle B, you have a couple of options. You have the side opposite, and you have the hypotenuse. So opposite and hypotenuse, that's an O and an H, so that's a sine ratio. But since you've calculated A, you could also use the adjacent and the hypotenuse, which is cosine. So you have a couple of options there. But in either case, you can go ahead and solve to find angle B. It's 20 over 32 using a sine ratio. So again, the opposite divided by the hypotenuse. Because for now we're trying to find the angle. There's your reference angle that's missing. And much like we've done in previous lessons, use your sine inverse in your calculator and come up with the result. And you do exactly the same thing, except with a different ratio, same concept though, to get your A value in there, and then, or your A angle, and then you've got your triangle all solved. You got all the angles and the sides that we're missing. Okay, so practice as many of these questions as you can. I'm just going to go through a couple more things just to help you out a little bit. So there are things you'll come across in terms of problems online and in the textbook. Something called a pitch of a roof. That's referring to the angle of the roof here. And as you can see, there's a little right angle built in here, so that's why right angle triangles come in handy. Wheelchair access ramps, again, they have certain measurements that are required to be used. Ratios much like ladders for safety reasons. There's also road information. As you can see, it's not a perfect right angle triangle, but the right angle is up in here. Okay, so anything to do with a right angle triangle, you can use the same sort of techniques. There is a question just to talk a little bit about the textbook, just quickly that was assigned. So you have this parent, so I'm going to read the question. As I read the question, I'm going to go through this diagram. So parents of Nicole have placed her school picture in a square frame and hung it on a wall. This one here. How do I know it's this one here? Because to the left of her picture is another square frame. So this is the left, there's another frame. And to the right is another picture frame. So that's to the right, and there's another picture frame. So the left picture frame is 1 centimeter smaller in length. Now, if it's square, and I don't know the measurements of the original picture frame, I can call it x. 1 centimeter smaller would be x minus 1. And since it's a square, both side lengths are the same. And then similarly for the other one, if it's 1 centimeter larger, x plus 1. All right, and then you're told if the sum of all areas of the three picture frames, so this one, and this one, the three areas together, the areas added together, so you see the addition here, is a grand total of 1325. You're asked to determine the dimensions in the frame that contains Nicole's picture. So in other words, you're basically asked to find x. It's a matter of setting up some algebra. All right, so you have different formulas you can use for finding the area of the square. It doesn't really matter which one you use because you're going to replace the information in there anyhow. So the three areas add together to give you 1325. So you put in the algebra that corresponds. So A1 is the smaller one, A2 is the original one, A3 is the larger one, and you're going to have to use the little distributive property to get that solved. Oops, sorry. So distributive property to expand and simplify, and then solve for x any way you can. So this is an example of solving quadratic equations. Okay. So any way you can solve and get your x. I know this isn't complete. It's just a matter of showing you the process. All right. So hopefully this gives you a little insight into solving some of the problems.